Hello, math application students, and welcome to your online lesson. Today is a continuation of our lesson on the t-test. We will be using a TI-84 calculator or similar to find p-values and interpret a t-test. And we'll know we're successful when we can use a t-test to determine if the difference with two sets of data are statistically significant. So again, a recap from last lesson, which if you haven't watched yet, you should watch before watching this video. We looked at a problem that had for each of its two sets of data, there was a data summary or a statistical summary. And let's take a quick peek at that example. And so it was dealing with dog walkers from the country and the city. And for each of our two populations, the country and the city, we knew how many samples were collected or how many members were in that population. We knew the mean and we knew the standard deviation. We did not know the actual values for each one of the samples or each one of the participants. We just had that three-number summary. Again, the number of samples or participants in the population, and then the mean and the standard deviation. And we knew it for both sets of data. So I just underlined the data that we had for the country, and then we also had those same three values: the n value, the number in the sample, the mean, and the standard deviation. Now, the example that we're going to look at today does not have that summary done for us. And so right away, looking at this second example, which we'll go through today, you can see that there is a table of values. And for each of our two populations or each of our two data sets, we don't have a summary. We don't know the mean yet. We don't know the standard deviation. What we do have, though, is all of the actual raw data values. So let's read this problem. A study was conducted to examine the differences between older and younger adults on perceived life satisfaction. 10 older adults over the age of 70 and 10 younger adults between 20 and 30 were given a life satisfaction quiz with the results shown below. And then we can see the actual 10 results for the younger participants in this table in that first row, and then the 10 results for the older participants, or the 10 scores for the older participants in that second row. Reading on, it says scores range from 0 to 60, with high scores indicative of high life satisfaction, low scores indicative of low life satisfaction. Use a t-test at a 10% significance level to test the claim that age does not affect life satisfaction. So right there at the end, it stated what the claim is. The claim is that age does not affect life satisfaction. And thinking about this in terms of our t-test, which focuses on the mean of each set of data, we would be saying there that the claim is that the mean of the younger population is going to be equal to the mean of the scores of the older population. And so on our next question, where it's asking us to state the null and alternative hypotheses, our null hypothesis is simply going to be, as it always is, that the means of each of our two populations or data sets are equal. And in this case, we'd be saying that there is no difference in the scores between the younger and older populations on this life satisfaction test. Now, the alternative hypothesis, usually the problem, or at least the problem we looked at last time, it said the words either greater than or less than, which let us know first and foremost that it was a one-tailed test, and let us set up our alternative hypothesis either using a greater than or a less than sign comparing our two means. In this particular case, it doesn't mention anything about younger or older being greater or less than the other. It's simply making a claim that the ages do not affect life satisfaction, therefore the means of the two groups should be equal. Therefore, our alternative hypothesis will simply say that the means of the two groups are not equal. So I've got labeled here H sub 0, which stands for our null hypothesis. It says age does not affect life satisfaction. And then written in our more math speak, we've got mu, representing mean for the younger population, and the mu for the older population set equal, which again is always our null hypothesis for a t-test. But then for our alternative hypothesis, H sub a, age does affect life satisfaction. And once again, we're not claiming that the younger will have a higher life satisfaction or that the older will or anything like that. We're simply saying that the satisfaction, the mean of these scores, will not be equal. And so this is what we would call a two-tailed test, because it's not just saying that one will be greater or one will be less. It's simply saying that they won't be equal. So they could either be greater or less than the other. All right, going on to the second question, it's asking for the p-value to this test. And last time when we had that summary, we were able just to put that right into the calculator and get our p-value and make our interpretations. This time we are given this raw data, and we need to get that into the calculator. the first thing you're going to want to do is go to stat, just like we did before. But we're not going to go directly to our stat tests. This time we're going to go to edit so that we can put data from our lists into the calculator. And this is just like putting data into a list, like if we were doing correlation on the TI-84 calculator, or even goodness of fit test. And so you click on edit so that we can actually put the data in. Now I've already preloaded this data into this calculator here, but I will demonstrate for one of the lists. I'll do the first one. Again, if you already have data in your calculator, just hit clear after highlighting the list itself. Hit clear and then enter, and it'll remove all of those values. And then we can just start typing in those scores. So I'll do that here for this first list of younger participants. The first one was 45, so we can enter in that number, then hit enter. It goes on to the next row in our list. 38, 52, 48, 25, 39, 51, 46, and then I've got to move the calculator a little bit to see what's under there, 55 and 46 for our last two datas. 55 and 46. Now, in this particular case, there were 10 participants in each one of the age groups, so we should have the same amount in our list 1 and list 2, and we can see that there. And again, if you don't have those second list values put in, you would do it the exact same way. Go to list 2 and start entering those values in. Now, once you've got all those values in, you can quit out of this by pressing second quit, and then we're going to go back to the stat menu, but this time instead of edit, we're going to do like we did last time and go over to tests. And we don't want the second option, which says t-test. We want the fourth option, which says a 2-sample t-test, again indicating that there's 2 different populations, in this case younger and older, 2 lists that we're using. So after we select that, previously we had used stats to do our t-test, where we had that 3-number summary with the number of participants, the mean, and the standard deviation. In this case, we actually have raw data. So you need to make sure that you are highlighting the data there. And you can see that the list of options changes dramatically once you do that. And the first thing it says is list 1 and list 2, and they default to L1 and L2. And that's where we put our list values. If you needed to change those, you could do that by pressing second and then the number 1, 2, 3, whatever it is. The frequency 1 and frequency 2, those should remain 1. Frequency just means how often they occurred, and if for some reason your list was doubled or tripled or something like that, you could increase that value. But for our class, they should always be 1. And then we get down to where it's essentially our alternative hypothesis. It says the mean of our first set of data is either not equal to the mean of our second data, or it's less than the mean of our second data, or it's greater than the mean of our second data. If it was either of those other two, this would be a 1-tailed test, but we've already established this is a 2-tailed test. And again, just looking back at our alternative hypothesis, we want the 2 means to not be equal. So we're selecting that first one. A reminder that for IB math applications, we will always select pooled when we have the option. And again, it should stay that way if you've used it previously. And then scrolling down, we go to calculate. So we can go ahead and hit enter. And we get a bunch of values here. The one that we are most concerned about to answer our question for part B is to state the p-value for the test. And we can see it's 4.7366 on and on and on. But right away, we should see that there's an issue. First and foremost, p-value is a percent, and so it has to be less than 1. And so if you see a value like 4.7, which is bigger than 1, then we know this must be in scientific notation. And as we go to the end of that number, we can see it's e-4, which means times 10 to the -4th power. Again, scientific notation. And so that means we would need to move our decimal place 4 places to the left. Move our decimal point 4 places to the left because it says e-4, like times 10 to the -4th power. So that would be 0.000474 based on our proper 3 significant figure rounding. And so that is our answer for part B. Now for part C, it says to state with a reason the conclusion to the test. So we are comparing our p-value to our significance level. Our significance level, as we saw earlier in the problem, is 10%. Or to say that another way, it's 0.1 or 0.10. So we're comparing this p-value to that significance level. We'll accept our null hypothesis if our p-value is greater than our significance level, and we'll reject it if it's less. Well, clearly, we are much less, with 0.000474 being less than 0.1 or 0.10. So our conclusion is that we are going to reject the null hypothesis because the p-value of 0.000474 is less than the significance level of 10%. The claim saying that age does not affect life satisfaction is incorrect. Age does affect life satisfaction. Now, to build on this, you could do this as a one-tailed test and make a new claim that maybe the older population is more likely to be satisfied with their life, and then you could do a one-tailed test with that, or you could do it the other way. But with our two-tailed test, it's simply saying that our claim is incorrect again, and that age does affect life satisfaction. The means are not equal. All right, that concludes our lesson for today. Till next time.